All right, this is AP Calculus Worksheet 5-8. This is the answer, the solution, the key. Whoa, that got all messed up, didn't it? That should have been moved over here to the left. I will fix that. But anyway, I need to find the integral between 0 and 4 as a review. So I need to find this area, which is 2. This area right here is also, I guess I could have made it a little bit different. I could have gone like this. There's an easier shape to find. That area is 4. This triangle up here is 2 by 1, which is 2. Half of that is 1. The area here, if this should have been 5. Bless you. Over here for this graph, I'm doing between 0 and 4 as well. So I'm making a line here. This area is -1 to 3 by 2, which is -6. This area up here, I have a rectangle that's 2 by 1, which is 2. I have a triangle that's 2 by 1, 2, 3, 4, which is 8, but half of that is 4. So 2 plus 4 is 6, minus 6 is 0. It cancels out. All right, so this piecewise function, this is going to be split into 2 different integrals. I have the integral between 0 and our suspect point 2 of my first one, which is 2x plus 4. Don't forget to do our dx. Then I'm going to add the integral from our suspect point 2 to our end, which is 6 of our last function of x, dx. When I take the antiderivative of 2x plus 4 is 2x squared over 2 plus 4x, evaluation bar between 0 and 2. All right, next antiderivative. Antiderivative of x, I guess I didn't really need these parentheses. Let's go ahead and delete those. They're just kind of annoying me. And then antiderivative of x is x squared, divide down by 2, evaluation bar between 2 and 6. Let's go ahead and plug these bad boys in. So 2 squared, these 2's are gone. They cancel each other out. So 2 squared plus 4 times 2. And then when I plug in 0, it's just minus 0. And then I'm going to add all of the left-hand side with the right-hand side. When I plug in 6, I get 6 squared over 2. And then I'm going to subtract whenever I plug in 2. So subtract 2 squared over 2. Simplifying another step further, 2 squared is 4 plus 8 is 12. And then 6 squared is 36, divided by 2 is 18, minus 2 squared is 4, divided by 2 is 2. So 12 plus 16 is 28.
That was on our notes.
Say it louder.
That one's on our notes.
Oh, is it the exact same one?
Exactly.
Oh, well, nice. Some good review. Something to check on your notes on. Do you guys appreciate that, or do you not like it?
I like it.
I like it. It's a free answer for me.
Okay, I like it also because it's something that you can definitely refer back to the notes and make sure you know how to do it correctly. All right, next problem I'm going to wait to do. And onto the back side, so we have this integral should be moved to the left. I don't know why it's so far over to the right. I'll fix that for later. It's going to be the integral between 0 and the suspect point 2 of the left piece, x minus 3, all of that dx. And I'm going to add the integral from the suspect point to the end of 2x plus 1, all of that times dx. All right, so antiderivative. Antiderivative of x minus 3 is x squared over 2. That's the antiderivative of that one. Antiderivative of minus 3 is -3x. Evaluation bar between 0 and 2. And I'm going to add the antiderivative of this one. And you might be thinking, wait, do I need to use taxman because I see parentheses? Maybe this is an inner, and then the derivative would be 2. And the answer is no, it's not really taxman because this is a power of 1. So basically ignore the parentheses and I just apply this antiderivative or this this integral symbol to both of these, and I'm ready to go. That only happens when this is a power of 1 or when there's nothing there. So just antiderivative 2x goes up to the power of 2, divide down by 2, and then plus x, evaluation bar between 2 and 4. All right, so how much room do I have? Plenty of room. Okay, so these 2's cancel out. Let's go ahead and plug in this 2. So 2 is now going to be squared, divided by 2 minus 3 times 2. And then let's plug in the 0. So we're going to subtract whatever happens when we plug in 0. That's going to be 0 minus 0, which is just minus 0. Okay, so that was the left-hand piece. I'm going to add it to the, I'll put like square brackets so that we know. That was the left-hand piece. And then this is going to be the right-hand piece. The right-hand piece, I'm plugging in 4, so I get 4 squared not over 2, so I can actually bring it down. 4 squared plus 4. And then I need to subtract what happens when I plug in 2. I get 2 squared plus 2. And I put parentheses around this because this minus sign is going to distribute into both of those two terms. So just be careful of that. When we do this, 2 squared is 4, divided by 2 is 2. 2 minus 6 is negative 4. 4 squared is 16 plus 4, so I have 20 there. And then 2 squared is 4 plus 2 is 6, so minus 6. 20 minus 6 is 14, minus 4 is 10. That's not right. 20 minus 6, yeah, that's 10. Okay, I was wondering what was going wrong, but I am doing the math correct. All right, 10. And our final problem, I think, final problem for all of our homework. I'm going to split this integral. This is now going to be the integral from 1 to the suspect point of 3 of 2 dx. And I'm going to add that to the integral from the suspect point from 3 to 5 of x minus 1 dx. All right, well, let's go ahead and take the antiderivative of each of those. I can actually go down below. I have tons of room in this one. So the antiderivative of 2 is just 2x, and that's the evaluation bar between 1 and 3. Next, we have antiderivative of x is x squared over 2. Antiderivative of minus 1 is negative x. Evaluation bar between 3 and 5. Let's go ahead and plug these in. When I plug in 3, I'm going to get 6 minus whatever happens when I plug in 1. 1 gets plugged in for x, and I get 2. So that was that left piece. I'm going to add this to the right piece. So the right piece, when I plug in 5, I'm going to get, that's a bad parenthesis, I'm going to get 5 squared over 2 minus 5, and now I'm going to subtract. I'll do a double set of parentheses here. I'm going to subtract this set of parentheses when I plug in the 3. 3 squared over 2 minus 3, and that is a 3. Let me make that 3 look a little bit nicer. That's a 3. Let's go ahead and simplify. 6 minus 2, 4, nice and easy. Plus 5 squared is 25. 25 halves. I'm going to leave it as 25 halves. Over 2, or if you, it doesn't really matter. I guess if you leave it, you'll cancel it out with this one. It'll be nice. 25 divided by 2 is 12.5, and then minus 5. Minus, okay, so this is going to be distributed, so I'm going to have minus 9 halves, or 4.5. And then this is going to be plus now, because negative is being distributed into each of these, which is going to be a plus, is going to be plus 3. All right, just got to simplify. So let's do some mental math. So I'm going to do the 0.5s to get rid of first. So 12.5 minus 4.5, well, the 0.5s are gone. And then 12 minus 4 is 8. So I have 8, and then I'm going to do just left to right. 8 plus 4 is 12. 12 minus 5 is 7. 7 plus 3 is 10. So I have 10 yet again. Cool. And that concludes the solutions to worksheet 5-8.